In this video, I'll walk through an example that evaluates an algebraic expression when we substitute in a complex number for x. Here's what the example looks like. Evaluate x squared minus 7x plus 8 when x equals 4 plus I. Now, just to start with, let me share a process that I find is very, very helpful. It works every time. If I rewrite the expression, leaving empty parentheses for x, so I have x squared minus 7x plus 8. Notice this isn't an equation, by the way, it's an expression. There's not an equal sign. The equal sign here, x equals 4 plus I, that doesn't make this expression an equation. There's no equal sign here in this expression. What I'm going to do though is I'm going to replace that x with the 4 plus I. And now it's simplifying. So I've got to recognize that this 4 plus I squared means 4 plus I times 4 plus I. Now you could spin your wheels foiling that, and that works. But you know what's even better if I recognize this pattern, that a plus b quantity squared is a squared plus 2ab plus b squared, just from having worked with this pattern enough. And now as a pre-calculus student, it really would be to your benefit to start embracing some of those patterns that could help you be more efficient. So when I multiply 4 plus I times 4 plus I, I'm going to get 4 squared, so 16, plus 4I doubled, so plus 8I, plus I squared. And don't forget that because I is the imaginary unit -1, if I square that, I'm squaring a square root, so I just get the radicand back. The radicand is a number inside the square root, so the square root squared of -1 is just -1. So this I squared will convert to a -1. Now be careful with this minus here, because this is a -7 times 4 and a -7 times I. So I would for this next piece, I'd get -7 times 4 is -28, and then -7 times I is -7I, and then plus 8 hanging off the end here. So simplifying this a little bit, I recognize that the I squared is just a -1. The 4 squared is 16. So I have 16 minus 1 minus 28 plus 8. Just to be clear, let me write those all out. We've got a 16 minus 1 minus 28 plus 8. I've grouped all of the real components together. And then I've got all of the imaginary components, the 8I minus 7I, right? So if I do that arithmetic, I'm going to get 16 minus 1 minus 28 plus 8 is -5. You could use a calculator if you prefer. 8I minus 7I is 1. 8 minus 7 is 1, so 1I or just I. And that's it. We've got -5 plus I. That's how you can evaluate algebraic expression when we substitute in a complex number for x. Hope that this video has helped you with that type of example. Let me know if you have further questions.